the maximum distance between two nodes. Your task is to determine the diameter of the tree. The first input line contains integer n, the number of nodes. The nodes are numbered 1 to n, each containing two integers n b. The region is between node A and B. The diameter of the tree. Distance between the two nodes. Your task is to determine the diameter of the tree. Okay. Between any two nodes, what is the maximum distance? So can we do it like this? So I think one way would be to just calculate the size of, so let's see. So if we have this tree, so if we calculate the size of every subtree with node, let's root this node at 1, let's root this tree at 1 and then calculate the size of every subtree. Then the diameter, how to calculate the diameter? For diameter, yeah, every possible option diameter might pass from here or pass from here or pass from here, right? So it can be this one. So it might have one more child. Okay, that would be easier. Okay, so it seems diameter will be the any two maximum child. So for this node, what are the two max childs, right? So this child. So size of the subtree size of the two childs, maximums of which who have the maximum subtree size. Like pick any two child who have the maximum subtree size. Okay, let's say this one and this one, right? Not subtree size but the distance, so it is 0 1 2, you can say height. Then it will be, let's say first node is this one, second node is this one, among all the nodes, then the distance will be, so it is, let's say height is h1, it is h2, we can say h1 plus h2 plus 2. This will be the diameter. So for every node we can calculate that. Okay, that works. But what if we calculate the other way? Pick any node and run a BFS from here, and find the farthest node, which is here, and from this node again run a BFS. Let's say this node I picked initially and ran a BFS. Then I got a node which is at the farthest distance. Maybe this one. Then from this node I again ran a BFS and got a node which is at the farthest node. So these two nodes will form a diameter. That means diameter will exist between U and B. Let's implement this one. Okay, easier one. Yeah, so we'll be given some number there and -1 each. Okay, typical tree. And then we have the n-1 edges. Let's have the adjacency of every node. You can write adjacency of x dot back y, adjacency of y dot pushback vertex. Okay, we have the graph created. Now let's run a BFS from any node. Let's say that node is 1. So BFS from 1. This will give me a vector of integer. Can say distance. What do I need? I just need that node which is farthest from this one. Then the second node, second case. So let's say BFS of 1 gives me S. Then I need to run the BFS from S, right? So that will give me, let's say T, or let's say U. First I got U, then run the second BFS from U, I got V. Can I say U and V are the, so that means farthest node from will be get farthest from 1, get farthest node from 1, get farthest node from U. So U and V are these nodes. Let's find the distances also. No. U and distance of U. It's written up here. And distance of V. We can return distance of U. What is the distance of U? I think distance of V will be the answer, right? Because that will be calculated from U only. So the difference will be the answer. D of V will be the answer. Okay, so run a BFS from 1 and get the farthest node from 1. From 1, which node is farthest? So let's say it is U, and its distance is du. Okay, do we need that du? No, we got the node U which is farthest from 1, and from U again we ran the DFS. That will give me from U again, so this from 1, let's say the DFS, this was the node U. From here again we ran a BFS which will give me the farthest node V. So that distance, the second distance dV, is my answer, right? Yeah, but can we return it like this pair? Let's say auto P1, auto P2. Can say P2 dot second. P2 dot second is that node's distance, the node and the distance, and its distance from the source. Okay, so it is returning a pair from a source node. What is the distance? Okay, so we have the source. So vector of integer distance of how many nodes? Let's say next. Let's write it here. Okay, fine. Every node is at distance 0. It's infinite distance. Now from doesn't matter because everything will be calculated. So from the, you can say distance of source is 0. Then go to, let's maintain a queue also, queue and queue dot push the source. Distance of source and while my queue is not empty, let's get that node u as q dot print. Yeah, I'm not able to type pop and go to all the neighbors of means adjacency of u. Go to all the neighbors of u, and if the distance of v is equal to infinite, that means its distance is not known yet. If the distance is infinite, we can say the distance of v will be nothing but 1 plus distance of u, right? You can push it also inside the queue. After this, I need to find that node which has the maximum distance. Okay, so let's see is BFS correct or not. So distance matrix q, distance of source is 0, q dot push source, while q is not empty. U is q dot front, q dot pop for every node. The distance of u, if distance of v is equal to infinite, distance of v 1 plus distance of u, right? So if it is infinite, then only update it. The distance of u is already 0, the source distance, and that's our infinite. After this, we will have the one which is the maximum distance. So let's say that node is 0. Let's say that node is 1 only, and distance of that node, if we need to maximize this, -1. Okay, so go to all the nodes. So if the distance of this node is greater than the current distance, that means current distance become this and answer becomes I. Finally, we can return the pair, what the node, and what is the answer of that node. That node will be answer. Okay, so did it work? I guess yeah. We read n. Okay, read the edges. X push back y push back x, and p1 gives me the get the farthest node from 1. Okay, and got, so p1 dot first is that node, right? p1 dot first is the farthest node. So from there, now I run the BFS to get p2, that the farthest node. What is the distance I need? What is the distance? Yeah, so p2 dot second. Let's see, get the farthest node from this source. So we create the distance q, source 0, push y, it is not empty. Go to this, if it is infinite, then distance of v becomes 1 plus distance of u, q dot push v, and answer is 1, and distance of that node is, let's say 0 or -1, doesn't matter. We need to find that node which has the maximum distance. So go to all the nodes. If the node, what is n, it will complain. So let's write here n. Okay, so distance of go to every, so distance of I is greater than the current distance. We need to maximize it. Okay, the answer is I. We can finally return answer and its distance, the node and its distance. We got the node and its distance. So from that node we got the node and distance, and we return the distance. Let's see. not be any compilation error. Overflow in conversion from LL to why it is. We need to see out it, right? Yes. In here something. Vector of LL. Okay, I think this should work. Let's try it. Diameter. Wow, worked. Great.